Hello, this video is going to be about how to find the molecular shape of a single center molecule. The learning goals for this video are to first learn and understand why molecular geometry is important, to understand the basic science and steps behind molecular geometry by briefly describing the Lewis dot structure and by briefly describing the valence shell electron pair repulsion model or VSEPR model, and to provide an example of a common single-center molecule and finding the molecular shape of it, which will hopefully allow the viewer to apply this method to other molecules. So to start, why is molecular geometry important? Well, the biggest and main reason why the shape of a molecule is important is because many properties of a molecule can be predicted from knowing the shape. These properties include things like phase, color, polarity, and how it reacts with other molecules. Molecular geometry can also be useful to know when making drugs or understanding molecular function. To understand how to find the shape of a molecule, one must first use the Lewis dot structure model. The Lewis structure is used to determine how atoms and molecules form bonds by using valence electrons. For a single atom, the Lewis structure is formed by writing the element symbol, using the periodic table to determine the amount of valence electrons it has, and placing dots, representing the valence electrons, around the symbol one at a time. For example, the Lewis structure of oxygen looks like this because it has 6 valence electrons. For a single center molecule, the steps are similar except that valence electron pairs are shared between atoms to form bonds. This can be seen in the carbon dioxide example. Here, shared electron pairs are represented by lines and the unbonded electrons remain as dots. Moving on to the valence shell electron pair repulsion model, or the VSEPR model, this is the second and final step that is used to determine the molecular shape of a given molecule. This model theory states that electron pairs in molecules will repel each other whether or not they are in bond pairs or lone pairs. Because of this, a molecule's atoms and their electrons will settle into positions that minimize repulsion to achieve a state that has the lowest energy. This translates into bond angles. By determining the amount of electron groups and lone pairs, one can find the shape of any molecule. This picture illustrates the geometry of different molecules based on the amount of electron pairs present and gives example molecules that fit the descriptions. Now that I've discussed all the steps to finding the shape of a molecule, I'm going to go through an example of how to find the shape of a single center molecule. The molecule I'm using is the water molecule H2O. So to start, the Lewis dot structure would be drawn like this because each hydrogen has 1 valence electron that is shared with the oxygen that has 6 valence electrons. Oxygen's remaining 4 electrons are then left unpaired. After this, using the valence shell electron pair repulsion model shows that H2O, a single center molecule, would have a tetrahedral geometry and a bent shape. So now I've gone over why molecular shape is important because it can give light on molecular properties. I have described the basic scientific explanation and steps to finding the shape of a single center molecule using the Lewis structure and VSEPR model. And I have completed an example problem of how to find the shape of a single center molecule using the steps I explained in hopes of the viewer being able to apply the same steps to other molecules. Hopefully now the concept of molecular geometry and steps to determining the shape are more clear. Thank you.